Hey, Vlad here, devinside.com. Welcome to another video. In the previous couple of videos, we took a deep dive into the world of JSON with Cersei. Today we're going to talk about a relatively unrelated topic, which is enumerations. We're going to see a lot of different ways to encode enumerations in Scala, including a library called enumeratum. And we will also take our first look at support for enumerations in Scala 3, which should come out in a year or so. Let's get right to it. Now, this video is going to be a little bit different from all of my other videos because there won't be much typing involved. See, there are many ways to encode enumerations in Scala, and I didn't want to waste your time. So what I did instead is I created a GitHub repository, which we're going to simply clone and go through. Before we do that, let's talk about what enumerations are and also why I've been making videos for over 3 years, and this is the first time I'm mentioning them. The reason for that being is that I very rarely use them. And that's pretty much it. I guess now we talked about it. In fact, I use enumerations so rarely that I had to spend quite a significant amount of time when I was preparing this video trying to remember why we even need them in the first place. Now here's my personal definition of enumerations, or enums. An enumeration is a way of assigning meaning to a seemingly arbitrary set of hard-coded values, also known as constants. Depending on your needs, you might want to constrain your definition of enumerations even further. During the preparations for this video, I brainstormed a little bit and wrote down a couple of thoughts. You might want the elements of enumeration to have an order. You might want to forbid repetition. You might want to be able to look them up by name. You might want your language to use the identifier name as the enumeration member name. You might want to be able to pattern match on them. You might want to be able to list them all. You might want to represent them with a distinct type, or you might want to make them refactor friendly by serializing them with an identifier which is different from its name. Traditionally, enumerations in programming languages were represented as simply a couple of integers. For instance, you could have 1 for north, 2 for east, 3 for south, and 4 for west. However, specifically in the statically typed languages community, there was a clear desire for stronger types to represent enumerations. And so a lot of statically typed programming languages ended up bolting some extra syntax on top of whatever was there before to support enumerations. And so they ended up being these weird beasts with some extra fancy special syntax. They're not exactly classes, they're not exactly interfaces, they're not exactly lists, they're not exactly sets. There's something in between. However, in languages like Scala, in which the encoding of the Curry-Howard-Lambda correspondence is relatively lightweight, syntactically speaking, we can just use ADTs with a couple of extra methods on top. And by the way, you might want to check out my video about the Curry-Howard-Lambda correspondence if you have no idea what I just said. Anyways, having said that, even in Scala, in production systems, you will very often find an encoding of enumerations which is slightly different from regular ADTs, because you usually get serialization semantics on the boundaries of your application for free, and it's really hard to say no to that. For instance, a JSON library or a database layer would easily encode enumeration. For example, oh, you have some sort of ID like 1 for north, so I'm going to store the integer 1, or I might store the string north. Whatever you prefer. And so here we are. We know what enumerations are and what they're used for. So let's just go and grab my GitHub repository and play with it. As in most of my videos, I'm using an Ubuntu 18.04 virtual machine, and I'm using Windows as a host, which comes with virtual desktops, which gives me shortcuts so that I can switch between Windows like this and back to Ubuntu like that. Alright, so let's just go to Windows again, and I already have it open in my Chrome over here. So the link is going to be down in the description. As you can see, there are two folders, Scala 2 and Scala 3. And each of them are individual SBT projects. So let me go to my dev folder, which is currently empty, and we're just going to clone it. There we go. Let's switch into that. Whoops. Like this. All right, so we have two folders. So let's open the Scala 2 with Visual Studio Code. And let me also switch to the workspace below so that I can go and I can switch into Scala 3. And for Scala 3, we need to say SBT launch IDE. Right, so if you've never played with Scala 3, what is happening over here is that it basically generates a project for, basically like Metals would generate a project for Bloop. It is generating a project for the built-in language server protocol support, right? So as of right now, Metals is not really supporting Scala 3 that well. There is already a PR, but it's very basic. So we would need another extension in Visual Studio Code for this to work. While it's importing, let's go back to the Scala 2 projects for now, and we're going to say import build. Now, the first way to encode enumerations in Scala would be not to encode them in Scala and simply use the Java enumerations instead. SBT will happily compile Java files for you. So if I go to source main, we're going to see Java and Scala. So let's open Java, and we always have two enumerations. So you're going to see why a bit later. The color one is a simpler one, and the planet one is a typical, a bit more complex one where you have compound constants. All right, Scala 3 finished. Let me actually move this one down to this one, to this other workspace. All right, so now we have both of them. Let me go back to this one. All right, so let's just open color Java, for example, and as you can see, I don't need any extensions for Java. All right, as you can see, Java has a built-in support, so there's a keyword enum, and you have some special syntax. It sort of looks like a class, but there are values and there are commas over here, and there's always a semicolon because it's Java. All right, let's take a look at Planet Java, which is more so this is the Java encoding of enumeration, which is why it's called Planet Java. In the Scala folder, I have Planet Scala and Planet manual ADTs and so on. We're going to go through this a bit later. Okay, so this is the typical example that you will find in most tutorials about enumerations. It's the encoding of planets. They have the order from the sun, they have the name of the planet, and they have the mass, and they have the radius. All right. So as you can see, we're using the same keyword, but we're implementing an interface, a trait, which comes from Scala. Let me actually create more space like this. All right, so we have the same like commas as we did was the colors, and then we have a semicolon at the end. This is a constructor. This is a couple of internal fields that the constructor will initialize. We're implementing compare in terms of order from sun. However, because the Java interfaces, they are not allowed to have methods, we actually need to implement all of the other methods that are usually implemented in Scala in terms of compare, so you don't need to write them all out, right? As you can see, they're all just calling compare. So this is the greater or equals and so on. And I'm using Fiora code, and I recently installed an extra plugin which allows me to disable the code ligatures if my cursor is on top of a ligature. So if I put my cursor over here, you're going to see exactly what is in there, which is really cool. Makes it super awesome for me to record tutorials. All right, let's scroll down and see what else we have. So we have a couple of methods defined inside on the enumerations, and we also have a couple of static things. For example, this is the gravitational constant, and we also are getting the values that are generated by Java. Values is an array. Arrays are mutable, and this is not what we're usually doing in Scala. In Scala, we usually prefer the functional way of thinking, and therefore we're going to use the array seek, which comes from Scala. So I'm importing it over here. So this is a Scala collection immutable array seek. And let me go back down, and it has a method called unsafe wrap array. So what's happening behind the scenes? So this is basically a performance optimization. So we're not copying the values from the array into some immutable data structure. All we're doing is we're wrapping the immutable data. We're wrapping the array, and all the methods from the array seek will just delegate to the array that is wrapped. And it's called unsafe simply because if you keep mutating the array behind the scenes, the behavior is going to be undefined. I also added a couple of more static methods. This one is called withIndexOption, which allows you to find your enumeration by the index. And the implementation looks very simple. We're taking an index collection, and the index collections in Scala, they extend a partial function from int, which is the index, to the element type. Now, we don't want a partial function, so all the partial functions have this method called lift, which would lift the partial function and make it total. So now over here, before this dot, we have a total function which goes from integers to an option of an element type. In our case, the element type is the enumeration, okay? And then we call apply on it because we're in Java. We have to explicitly call it, pass it the index, and what we're getting back is the option of a Planet Java. We also can look it up by name. Planets have names. So we're going to the collection, calling find, and lambdas finally ended up in Java. And we shouldn't forget to call equals because, again, we're in the Java world and not in Scala. All right, so let me open my Explorer again, and we're going to see that we also have Planet Java main over here. Let me start SBT. In the meanwhile, over here, we're going to have the terminal, and we're going to do SBT. All right, and I'm going to collapse this while it starts. We're just going to go through this, okay? So the first thing that is happening is that we're just basically getting out the values, which is the mutable array, okay? And we're using a function called tab. If I jump into it, we're going to see that I have a package object defined over here. And by the way, if this thing is not open, you can always see it in the breadcrumbs over here exactly where we are. So these couple of functions, they're actually defined in the Scala standard library, but they're under the import Scala util chaining, and I usually don't like to have this import, so I usually define these methods myself. We played with these functions in the video about function juggling. You might want to check it out, but basically it allows you to sort of like chain function calls, right? So you're not chaining functions, you're chaining function applications, so to say. It's hard to explain. All right, so basically we're having this array, and the array is going to be assigned to this value, but we're also tapping into it, right? So we can perform some side effect without like changing this expression, basically, okay? So we're tapping into it, and the default toString for arrays looks very ugly in Java, and therefore we're going to do make string, and we're going to say that it should start with this, split all the elements by this comma, and in the end also append this closing parenthesis, and we're taking this string and we're piping it into print line. So pipe actually does change the type, but in this case we don't really care. We just want to tap into the whole thing. All right, so if I just do run, or if I'm going to do run main, actually let's maybe compile the whole thing. And by the way, I also have tests. Well, technically I don't have tests. I'm going to show this a bit later too, right? But if I run the test now, then the whole project is going to compile once, and then I won't need to waste your time anymore. Okay, we're going to talk about tests a little bit later once we're going to start talking about the encoding of enumerations with enumeratum. Okay, let's close this one for now, and it should finish compiling in just a couple of seconds. There we go. So now we can do run main, and I'm going to do tab, and this is going to be planet Java main. All right, so as you can see, this is the first thing. So we're just printing out this array, nothing fancy. The second one prints out the array seek, right, which just wraps the array, which is over here. As you can see, everything is ordered like as it should. Okay, then we're looking it up by index, right? So for example, the index 2, which is the third planet, which is Earth. So we see some Earth over here. We also can look it up by name. Again, nothing super fancy. We're getting ordered our semantics. So the Earth is closer to the sun than Mars, so therefore we're seeing true over here. Also, we have an overloading test, and you're going to see why once we're going to start talking about the encoding of enumerations in Scala. But as you can see, overloading works. So this one works for planet, and this one works for colors, which is also the reason why I had 2 enumerations instead of 1. And also, it produces warnings when we try to pattern match on it. I just commented it out because I didn't want to have warnings printed out over here. But it's really important to know that the warnings are actually produced, and it's going to be clear why again once we're going to start talking about the encoding in Scala, which is actually now. So we can actually press enter over here and switch to planet Scala main. All right, let's go to see the code. So we're going to have planet Scala. Okay, so Scala also has a built-in support for enumerations. However, it's not a special syntax, so it's not a keyword. It's just a class that you extend over here. You extend this class, and then this class inside, it has a class inside of it called value. It's a protected class, I believe. So the first thing that we're doing here is we're creating simply an alias. This is completely optional, right? So outside of this, once we're going to start looking at the main, you're going to see that we could use planet Scala.value. However, like usually, like this is what's recommended in most of the tutorials, so that you have like an alias, so that in the methods where you're using this thing, you're going to use the type is going to be planet Scala.planet Scala. In fact, if I scroll down a little bit, like somewhere to the main, you're going to see this exactly here. Planet Scala.planet-Scala or planet Scala.value is also going to compile, and it's going to do exactly the same thing. Let me actually revert this one. All right, so let's go up. So Scala doesn't have any statics because this is an object, so you can just have a val over there. So this is the gravitational constant. This is necessary if you want to change this inner val class. In fact, I'm realizing that just now that we should probably start with the color one, because the color one is much simpler. So this is the color one, right? So we extend enumeration. We're creating another alias saying value, and then we're assigning a bunch of we're creating a bunch of variables, and we're assigning the value of value to all of them, right? So this is just a special syntax. You can do val ABC and ABC, and you can just assign value like 1 through 37 to them, right? So this is valid syntax in Scala, just a shortcut. Okay, so value is not just a class, it is also an instance, like somewhere inside of enumeration over there, right? So it's a type, it's a class, and it also has a companion object, right? So it's also a thing. All right, so let's go back up. So over here, we want to have a compound constant, right? So planets are composed out of a bunch of constants, like these three. So we go ahead and we actually extend the this class that is defined inside of the enumeration class. So if I jump in there, you're going to see that this is just a protected class. It has some notion of a name and it has some notion of ID. If I scroll down a little bit, you're going to see that there's a def ID over here, which uses this I. Okay, let's go back. Let's go back once more. All right. So we have the the couple of methods. They look very similar. They look very the same. In fact, I'm not even calling these methods in my mains. Okay. We can use the toString as the enter name. A bunch of things are generated for us. Okay. So we also have this implicit conversion from a planet to a val. This is necessary for some internal things. You don't really need to care about this. Okay. Now the actual values are simple vals. Okay, and their type is planet Scala, or or value. It's just an alias. Okay. And we're just creating this val, right? So val is now a case class over here. So we're just giving it, the order from the sun and, the whatever it was, the mass and the radius. Okay, just a creation of instances of a regular class. Okay, now it comes in with values which are also generated for us, similarly to Java. However, the type of this is some sort of weird value set. We're going to see it a bit later once we scroll down to the main. Okay, but we want to convert this set to an index seek and also to sort it. This is usually a common scenario when you want to display a drop down, for example, where what the user will be able to select, for example, the favorite planet. Okay. We also have with name option. The implementation is basically the same as in Java. We go into values, calling find. Just the lambda looks a little bit nicer. Okay. With index option also looks very similar. We're lifting the partial function, which is an index sequence. We're giving it the index. We're getting an option of planet Scala. And we're also mapping this option into this funky looking thing called ensuring. This is part of the standard library, and it basically just does this assertion. And if the assertion fails, it's going to throw an exception like a regular assertion. Right. So this is just a better syntax for for doing an assertion manually, like doing like this, and doing like that, and removing that, and saying that this is going to be the result, and returning the result over here. But before we return the result, we would do assert, blah blah blah. So this is just like a better syntax for that. Let me revert all of that stuff like this. All right. So all we're doing is we're ensuring that the order from the sun is off by one from the index, and I'm doing this basically to ensure that this value sequence is sorted. Okay. And we're also making sure that this index is the same as the ID that was generated for us. Okay, so this is pretty much it. Let's start looking at the main. Okay, so the first thing that we're doing is we're printing out this set. However, this set was actually sorted for us. In fact, if we if you jump into this, we're going to see that it's not just a set, it is a sorted set. Okay, so this is just a special version of a sorted set. It's optimized for performance because underneath it uses a bit set for the IDs. All right, let's go back. The next one prints out, the sequence, nothing fancy. Looking it up by index, it's Earth again. Looking it up by name, it's Earth again. All right, and we're also seeing over here that the ordering semantics are fine as well. So the Earth is closer to the Sun than Mars. However, and these are the problems for which come was the default encoding of enumeration, and also they're also the reason why there are so many different other encodings of enumerations in Scala, because we want to try to avoid these problems. The first problem is that overloading doesn't work. So if I comment this out, it's going to say, it's basically going to look at planet Scala and at color Scala as if it was the same type. It says double definition. It can't differentiate between them because this type gets erased, which is unfortunate. All right, and the other one is pattern matching. As you can see, this thing has been here all along and we haven't seen any warnings. If I was even to clean and to run that again, you're going to see that it's going to compile, but it's still not going to produce any exhaustiveness check warnings, which is also kind of unfortunate. So I believe this is all we need to know about the default enumeration encoding in Scala. Let's start looking at the manual version, right, which is going to be basically a regular ADT with a couple of extra methods on top. Okay, so it's just a sealed abstract class. It just has a couple of fields. We extend product with serializable. We're extending ordered, which is the same ordering as we were using in Java. We're using the Scala ordering. Now we only need to implement compare. We don't need to implement the greater equals and stuff. In fact, I'm forgetting, but I should always start with the one with the color. So let me collapse this one. Right, so this is the standard, 101 ADT, the manual, encoding of enumerations. You just have like red, green, and blue. That's all you need. Okay, now let me open this one again. So this is the companion object. Hold on, let me open the class. Let me actually create a bit more space. All right, so it's a regular ADT, right? So we have, basically a static thing in there because it's an object, right? No, this is not, this shouldn't be here actually. This is a constant, so let's actually put this one in here. All right, I'm going to commit this later, and because even though it's private, we should be able to access it over here. But now it's in an object, so we would need to do something like this, or we would need to import it. I'm actually not sure what to do. Let's actually import it, even though we're using it only once. Let's do something like this, like that. There we go. All right. So so we have just the regular two functions over here, and we can also use the toString as the entry name. All right. So let's start looking at the main. Let me create a bit more space over here and scroll down, maybe a little bit more space like this. Let's scroll down. Oh yeah, I also have these. So we forgot to look at the companion object, right? So the companion object is just a bunch of instances of an ADT. Again, this is a standard ADT. We don't have any built-in thing that would generate the values, right? So this index seek for us. So we have to do it manually. And I'm also sorting them in case one of my colleagues comes in here and sorts them by name or something. So yeah, we also have with name option looks the same. With index option also looks the same. They all look pretty much the same. All right, let's start looking at the main method. In fact, let's not forget to actually run it. So this is going to be planet. What is it? Planet manual main. Okay, so this is going to be the one for the manual version. Okay, so the first thing that we're seeing is our vector, which is a default index seek. I forgot to mention that, right? So we created it manually, so there's nothing fancy about it. It's sorted and so on. Okay, looking it up by index, the same. Looking it up by name, the same. Ordering the same, we get true. But now overloading actually works because now this is a proper ADT, and also pattern matching works and produces a warning. I commented it out again because I don't want to have warnings, but as you can see now we get a warning. It says match may not be exhaustive. It would fail on all the following inputs, and you see all the inputs except for Earth. Let's comment this out, and yeah, so there's nothing fancy about this. This is basically just an ADT with a couple of methods on top. Now, this was basically the best way to encode enumerations in Scala for a very, very long time until a library called enumeratum came up. Okay, so if I go to my build, you're going to see that we're using enumeratum over here. Which is this one. And enumeratum also comes with a couple of integrations with Scala Check, with Circe, and with Cats. I'm going to play around with them a bit later. Okay, let's start looking at them. Okay, let me this time not forget to collapse this and this one as well, so that we can start with looking at the colors. Okay, so it basically looks like an ADT. We're just mixing a couple of more things. So we're mixing the enum entry from this import, so we need only one import, enumeratum underscore. So we're mixing this one into the class, and we're mixing this one into the companion object, right? So we're going to say, so this is going to be an enum for this class, for this type, Scala enumeratum. Okay, so we can define values ourselves if we want, and it's going to be an index seek, or we can use a macro which is going to generate them for us, right? So we can just call find values. It's going to generate the macro based on these guys. All right, but apart from that, this is a regular ADT. All right, let's start looking at the more complicated one, which is the planet order. Let me go over here. All right, so this is going to be the class, and it mixes in enum entry dot snake So by default, you can just mix in enum entry, right? So you can do something like with enum entry like this. Okay, so both of these compile, right? So as we did with the colors, the class mixes in the enum entry. However, you can also modify the name. So it comes in with a bunch of so-called stackable modification traits. And if you don't know what these are, you might want to watch the video about traits that I made almost like 3 years ago, actually. Okay, so essentially it will change the name for you. Okay, so if I jump in there, you also see, snake case, and you have the upper snake case, you have the uncapitalized. You have a bunch of them, right? So we can actually also see it in the auto completion over here. So you have the camel case, capital dot case, capital hyphen case, everything you need. And notice that, they're stackable, so you can use, multiple at the same time, right? So for example, you want to have capital snake case, right? So, or like uppercase, snake case, or whatever you want. Some of them also come compound built in for you. Like there's probably uppercase, upper snake case, right? So, but if I use this one and if I jump in there, you're gonna see that this is just a capital snake case with uppercase, right? But you could have done it manually. Let's revert all of that. So let's just use snake case for now. I just wanted to showcase, something, even though like technically planets are not a good example for snake case because they're usually just one word, so there are no underscores. We're implementing ordered ourselves, implementing compare ourselves in terms of the order from the sun. Again, I made the same mistake with the G, so this is actually, well, it's not a mistake, it actually doesn't really matter. Okay, but we can go and put it over there. Okay, and access it, import this guy over here. I'm gonna commit this thing once I'm done. All right. So yeah, we have like these methods, same as before. Nothing fancy. All right. Let's start looking at the companion object. The instances look exactly the same because essentially this is an ADT, right? This is just a library that comes with a couple of traits that we mix into our ADTs. But apart from that, it's just a regular ADT. We're also implementing an instance of order for cats, but we're going to talk about this a bit later. Okay, so we have our values over here. We're using the macro find values. We're also doing ensuring. Ensuring basically is going to make sure that it comes to us in a sorted version, which it does. With index option looks the same as before. Okay, notice that we don't have to have this like with name option. It's already built into enumeratum. All right, so let's start looking at the main. Let's not forget to run it. So this is going to be planet enumeratum main, this one. All right, as you can see, there is much more output because there are integration and integrations with other libraries, and also there are a couple of helper methods. So let's scroll up. All right, so this is the beginning over here. All right, so we got our values, which again, if I jump in there, we're using the macro to generate these values. They come to us in a sorted version, and it's a vector because the vector is the default index sequence. All right, we got the instance by index looks the same. We got the with name option looks the same, but this time I didn't have to define it, right? So this time it's defined inside of enumeratum, which is cool. All right, ordering works the same. Overloading works. The pattern match produces a warning because again, this is just a regular ADT with a couple of extra traits. Okay, let's comment this out again. Now it comes with a bunch of helpers. So for example, we're saying over here with name option, and we're passing it earth was a capital case. We're tapping into it once to have a print line, and we're also mapping into the entry name so that I can show you that snake case actually modified. Now in this case, we're not actually going to find anything. So in this case, it's going to be none, right? Because we said snake case, snake case by default is actually lowercase. So if we're looking it up like this, it's not going to be found, and therefore in this print line we're also not going to see anything. Okay, the same thing for this guy, and this guy looks it up exactly the same, but it would have been converted into an either for us instead of an option, right? So again, just another helper method. But in contrast to option, which just basically tells you that an operation failed, and either also gives you the reason, which says enumeratum no such member, earth is not a member of enum, and gives you the entire enum. And over here you can see that everything is lowercase. All right, over here you have a couple of more helper methods. So this one says with name insensitive option. So basically it doesn't care in which case you give it, it's going to find it, which is why we see some earth, which comes from this print line over here. But the name is earth lowercase, which we see from this print line. Okay, so the entry name is lowercase, and the actual the actual toString is uppercase because the toString was generated because these are regular case objects, right? So this is a regular ADT. So let's continue. So over here we're basically looking it up. So this one is only going to match when what you're passing in is lowercase, right? So not because the value is in lowercase, but because what you're passing in is lowercase. And the same thing for uppercase, right? So we're passing in this one. These are going to be these two print lines, right? So we're looking it up by here. So this is the first print line, and this is the second print line, okay? So even though the value is lowercase, because what we're passing in is uppercase, and we set, match by uppercase, it's going to find it. All right, and this is pretty much it about enumeratum, about the default stuff. Let's talk about the integrations now. So if we go to the class, we're going to see that we're not doing anything extra, but if we look into the companion object, we're going to see that we're mixing the cats enum and Circe enum. Let's talk about cats enum now. So we're mixing it in, and I also implemented the cats. I don't believe that you're forced to do this actually, right? So obviously it's not going to compile somewhere at the bottom because this instance is not there, but at least this trait is not forcing you to have an order, right? But we can have an order, This is the cats order. And yeah, so basically all you need to do to have support for cats is to mix this in. And what it gives you, it basically gives you instances for show, equality, and well, and order. Maybe something else, I don't remember. All right, so if we scroll down over here, so we're importing cats implicits, which is necessary for this triple equal sign. And I love my extension, which allows me to just put my cursor over here, and then you're gonna see the actual, the actual characters. Okay, so yeah, so we have the equality. Don't forget that the type classes in Scala, well, not in Scala, but in like functional libraries like cats, they don't like subtype polymorphism, so you always need to make sure that you're using the type of the enumeration and not like this very specific type. For example, if I take planet Earth and I put it over here, it's just not going to find the instance of this type class, okay? So it's going to say that this value is not there. Okay, let me revert that. So as you can see, it works just fine. True, false, false. Okay. Let's see. Okay, cats order, right? So we're getting the values. We're doing toList, which I'm not sure if it is necessary actually. Yeah, it is necessary, okay, because we have the instance for list, not for the vectors, and we're calling maximum option, which is somewhere inside of cats, and for some reason metals cannot jump in there. However, these days actually the standard library has max option as well. So Neptune is the furthest planet from the sun, which is why we get this. But as I already mentioned, like these days, the standard library actually has max option. Okay, max option, same thing. We get Neptune. All right. All right. So the next thing is Circe. If you have seen my 5 videos about Circe, this is a JSON library. So we're mixing in Circe into the companion object. Okay, Circe enum over here. We don't need to do anything extra. All right, so let's go down, and we're importing the syntax so that we can encode JSON. Okay, so we're using planet A, and again, very important, the type is planet enumeratum. If I put this thing in there, it's not going to compile, I believe. Right, it's not going to compile. Okay, so we need to use the upper type so that we can use the as JSON thing that comes from the syntax. All right, as JSON, and we're printing it out. And notice that it doesn't print out all the constants. It just uses the string, which is sort of like used as an identifier for your entire enumeration, right? So this is the JSON encoding that you see over here as well. Okay, and then we're trying to decode. For this, we need a parser. So we're taking this string, right? We need to make sure that we have quotes. As you can see, there are quotes over here. And we're piping this thing into decode, planet enumeratum. Decode comes from the parser, and we're seeing that it actually worked and Earth came out. Now, this is pretty much it with this example. Enumeratum also allows you to have so-called value enums, which are enumerations which are backed by an identifier which is different from a string. Technically, it can also be a string, but it will behave a little bit differently. Okay, so we're going to have enumeratum value main like this. All right, and we're going to have it over here in enumeratum value. Let's close the other one. All right, so I marked all the places which are different. So this is the first thing that is different. We're having a different import. We're not importing enumeratum, we're importing enumeratum values. Okay, the rest looks very similar, but we're forced to override a value. And as you can see, metals came out recently. Was this thing that allows me to jump to the parent, which is over here. All right. It forces you to specify the value, and the type for the value comes from this guy, right? So this extends, an int enum entry, and you also have, long and short and so on. All right. You also have the string enum entry, but it's going to behave a little bit differently. As you can see, this is similar to the default enumeration, but it's different in that values must be literal values. This restraint allows us to enforce uniqueness at compile time. All right, so yeah, product serializable order, the same thing. In this case, no, we're still implementing order ourselves. Okay, I also did like order from the sun, and I said that it's going to be the same thing like as the value, and also I said that we're going to use the toString as the name. By the way, in the previous encoding of the enumerations, it is not possible to use the same value for the toString as it is for the enter name, because the enter name is implemented in terms of toString, and then you would have an endless loop. Okay, so we have compared the same. We have the constant the same, which I'm going to bring down into here. And let's import that guy. Import that guy. There we go. The values are the same. It's all the same. All right. Yeah, so it also, okay, just a companion object mixes in. Okay, we're gonna talk about cats and stuff a bit later. Okay, so let's go scroll down and yeah, so the companion object has the values. There's the same way generated by the macros. With index option looks like this now. And with name option is not defined by enumeratum. Now we have to define it ourselves because it doesn't even assume that your enumeration is going to have, some notions of strings. And also, this is a word of caution. Like if you're using enumeratum value, right? So the values they're going to be backed up by something like an integer. You probably don't even want to offer methods like this that would allow you to look up your enumerations by string. Because what's happening is that one of the benefits that you get of this is obviously it's more efficient, right, to store an integer in the database than it is a string. It's more efficient to look it up and so on. But the point is that by using something else than a default, toString or something as an ID, this allows you to refactor your planets without, destroying, without breaking breaking your API or breaking something in a database, right? So I could just go and, rename Earth to, I don't know, Earth 2 or something, and, all the code is still going to work. Obviously some things are not going to compile, right? But, the value in the database is still going to be, 3 because, Earth is, the third planet from the sun. Okay, but it allows you to refactor stuff. Whereas with the regular enumerations, if you refactor something, the toString changes, and the lookup in the database you need to run through a migration. You need to make sure that if you expose this in your REST API. All right, I'm talking too much. Okay, so yeah, I forgot to show you the colors, but they're basically the same, right? So you're basically extending an int enum entry, and in the object you say that this is an int enum instead of just a regular enum. Okay, so yeah, let's start looking at the main, and we are running the value main. So we're gonna have the values, which is the vector, same as before. Instance by index works just fine. Instance by value, right? So this is a bit different, right? Because we can, so this thing comes from enumeratum. It's built in. It allows you to look it up by the value, and the value is the order from the sun, right? So it's the index and the value they're offset by 1, okay? Because usually it's the indexes are starting with 0, they're 0 based, okay? Again, instance by name usually should not have this, but I just added it to show you that it's possible because it's just an extra method on the companion object. Ordering works the same. Overloading works the same because it's just an ADT. You get exhaustiveness checks because again it's just an ADT. And what else? Yeah, so these more capabilities that we have from the regular enumeration, they're not there because most of them were based on looking up names, looking up strings. Okay, all right, so now let's talk about cats. So for cats, we need to mix in cats ordered value name. There's also like a regular cats value name without the ordering. But if you're doing the order, then you don't have to implement the order yourself, right? Because the order will be based on the value, right? So we're importing cats implicit so that we have an ordering for integers, and if we have an ordering for integers, then enumeratum can generate an instance for us for ordering for planet enumeratum value. Okay, one of the things that you should know is that this guy is a class, and therefore you might need to rearrange a couple of things over here and to start with an extends. Okay, and later we're going to talk about Cersei, but basically now we're going to say int Cersei enum and not just Cersei enum. All right, let's go down. We're going to see the same comparisons, work the same. We have true, false, false. The ordering works the same. And JSON works the same, but now what is being serialized is just a number 3. This is exactly what I've been talking about. I can rename Earth, but I'm not going to break the API. Okay, and over here, what we're decoding now is going to be the value. Okay, it's just that this decoding parser it wants a string, so we're also doing toString. Okay, but we're actually going to the actual value, which is the order from the sun. I believe that this is actually it for Scala. Oh no, well, there's one more thing. There's the example suite, right? So one of the things that comes with an enumeratum, right? So these are the the integrations with scats and with Cersei. By the way, notice that they have slightly different versions. All right, what it comes with this thing called enumeratum Scala check, and notice that I have this comment saying that this is not necessary. Okay, so if you go to my example suite, which is over here, right? So we have example suite and we have test suite, and example suite extends a test suite. All right, so I have a bunch of comments over here. So for property-based tasks, you might want to generate instances of your data. So in our case of our enumerations, and if you have this import, then you will have the instances for the arbitraries for Scala check, and this code will compile. However, this code would not compile. Okay, so if I go to test suite and I disable, this is a different library that I'm using called Scala check shapeless. So I'm going to remove this. By the way, there is a video where I created this template a long time ago. You can go and check it out. Okay, but if I go to dependencies.scala, I'm actually using a library called Scala check shapeless, which based on shapeless generates a bunch of arbitraries for me. So now that this thing is gone, we already see a problem over there. Okay, so if I'm going to try to run the tests, or to even compile the test, it's not going to compile because it's going to say, hey, I can't find an arbitrary for a person. What the hell is a person? Person is just a case class, which is where is it? Hold on, example suite. Person is just a case class which is defined over here, right? Which uses some sort of name, and it has a favorite planet. Okay, so now it can't generate this one. So this import only helps you for generating a very simple simple arbitraries. However, usually you would want like some sort of compound arbitraries, and so you're going to use the Scala check shapeless or some other library like Magnolia. And then in this case, you don't even need this import, right? You can just comment it out. Everything is still going to work the same. Notice that I don't have proper tests over here. I just wanted to make sure that it compiles. Okay, so let me revert that, and let me okay, this is already revert. All right, now let's go to Scala 3. Let me go down to my other workspace. I'm going to go to the terminal. I'm going to start SBT in there. All right, this was actually the first time that I was playing with Scala 3. So this is the same template that I used for for the other project. It's just that I removed the tests because I didn't want to bother trying to make them compile. So the only difference is that you have is if you go to the plugins folder, we're going to have this sbt.dotty plugin, which basically makes sure that if we go to our build over here, that the Scala version that we're specifying is not going to be the Scala 2 version. It's going to be the Dotty version, which is going to change pretty much every week. Okay, everything else is pretty much the same. We don't need the so in this other project, if we go to the build, we're using the kind projector plugin somewhere over here, which was exactly where the cursor was. We weren't using it in this project, but it's already part of the template. In Scala 3, it's already built in. Okay, so we don't need it, so I removed it. All right, so nothing special over here. A couple of flags changed, like for example, for some reason it didn't like language underscore, but this one worked. And Scala 3 came with Python-like indentation-based syntax. Most people don't like it, so there's a way to sort of like disable it. It's still enabled, but you get like some sort of rewrites for you. Okay, so you didn't like this rewrite and no indent, and things are going to work fine for you. All right, so we have only one file. I believe I showed you actually everything that we need to know about this, right? So it basically has only one file, which is over here. Close others. All right, so SBT probably already started. Let's actually run this guy, and there we go. All right, so Scala 3 comes in with an actual keyword, enum, but behind the scenes it generates an actual ADT for you, and therefore, the exhaustiveness checks and everything is going to work. Okay, so it basically looks like a class, has a couple of vals in there. We're extending order, implemented it ourselves, same as before. Again, we have this private val G, which I'm going to cut out, bring into the companion object. You still can have a companion object, right? So this is not a problem. Let's see, import planet like this, and see, like already probably we're getting like these weird warnings about indentation. Like if I did the same thing in Scala 2, then the Scala FMT would fix this for me, but now we're getting like a bunch of warnings. And by the way, this would actually be not just a warning but an error if I didn't enable if I hadn't enabled like these flags. Okay, I believe. All right, so yeah, notice that we also don't have Scala FMT, so I need to do some of the things manually. Okay, so we have the compare, we have the service gravity, we have service weight, same way as before. Notice over here we're not saying case object, we're just saying case. Okay, but everything else is basically exactly the same. What else? Yeah, so again, indentation, I need to fix it myself. Yeah, so we have planet, and for some reason it comes with values, right, which are generated for us. We don't need to do it ourselves, but for some reason this is actually an array, probably for compatibility reasons with Java. We're doing the same thing as before. We're basically wrapping it into an unsafe array, or unsafe wrap array. However, for some reason, like this array with values, it is actually coming, being unsorted. As you can see over here, this is the first print line. We're going to look at it a bit more a bit later when we're going to scroll down. But it comes in by default as unsorted. It might be a bug, Scala 3 is still being developed. So I'm sorting it myself. And you can also sort it by ordinal. And ordinal is the same thing as, this I thing that was in the let's actually jump in there. Maybe we can. Okay, we can't. But if we go to the other project and we're gonna look into Planet Scala, I remember we were doing over here. We were creating our class by extending superval, and if we go in there, there was this I, right? And the I was basically the ID. So now it's called ordinal. Okay, same thing as the ID basically. All right, so I prefer actually kind of this one. All right, we're gonna have with name option. We're gonna define it ourselves, same as before, looking it up by toString. Same thing was the index, all the same. We're using ordinal over here instead of the ID. Okay, this is another version, right? So with the colors, looks very, very simple. We're using RGB, we're using the hexadecimal literals. We can do this in Scala 2 as well. Again, notice that there is no case object, it's just case. Okay, so this is the main method. Again, we're calling values first, which is an array, and for some reason, again, it's not sorted. I don't know why. Probably just a bug. Value sequence, the same thing. Array seek. Instance by index works the same. Instance by name works the same. Ordering works the same. Now overloading actually works, and pattern matching actually produces exhaustive mischecks. All right, there we go. Warnings look a little bit different in Scala 3. Whatever. All right, let's comment this out. And yeah, this is actually basically already it. This is pretty much all I wanted to show you. The last thing that I want to show you is that there's also another potential encoding of enumerations in Scala 3. I didn't want to include it into this repository because it's still, I don't want to encourage you guys to use it because like the default built-in enumeration is probably going to be the one that you should be using. However, I'm going to show you a couple of things and that came with Scala 3, and the combination of them allows you to have a different encoding of enumerations. All right, so let me do, what am I going to do? Okay, so I want to go and go to all the print lines and comment them out. All right, let's see if it's going to work. Obviously, I broke a couple of things. Print line hyphens. Oh, okay. Right. So I don't have a companion object over here. I had this guy down there. Okay. So this is also one of the things that you can have in Scala 3. Notice that this thing is like outside of the object. This is possible in Scala 3, right? So you don't need to put things into companion objects. Not companion, the package objects. Package objects, I believe, are still there in Scala 3, but at some point, I believe that they're going to be deprecated. You can do like 99% of the things with these guys. The only thing that I believe you cannot do anymore is like, if you have a package object, you can actually have some implicits and some trait. You can mix them into a package object. This is not possible over here anymore. Maybe there will be some other thing to make it possible. In any case, so okay, so we're also having like too many hyphens. So this guy and this guy. Yeah, there we go. Okay, so let's have a final case class person, which has a name and age, and also have a final case class wolf, which just has a name, for example, because wolves don't have ages. I don't know, maybe it's a weird example. Okay, so one of the things that we can do is we can encode a sort of anonymous ADT, anonymous sum type by using either, right? Person, wolf. Okay, and we can also do the same thing the other way around. If wolf2, it's going to be a wolf or person, right? So this is going to be a werewolf. It can be either a person or a wolf at the same time. All right. Now in Scala 3, you also have a different encoding of this, which is more syntax friendly, and it behaves a little bit differently. Okay. This is called union types. Okay, so we have person or wolf like this, and it should be called 3 because we already have 2, and 4 is going to be this wolf and person. So this is one of the differences. Like these two types are the same. because the union types are commutative. However, to the compiler, like these two types are different. Cool. So this is the first feature. The other feature is a feature that we already have in Scala 2, and this is singleton-based literal types, right? So these are singleton types that are based on literals. Okay, so we can have a val x, and we're going to say that the type of it is not an integer. The type of it is going to be 3, which means that the only value that we will be able to assign it to it is going to be 3. So as you can see over here, it says found 5 and wanted a 3. So if we pass it in a 3, it's going to compile. Okay, so we can do this with all the literals except for the functional literals because they're not actual literals. Okay, so for example, this hello works, but as soon as I ruin it, it's not going to work. Okay, so now what we can do is we can use the combination of these features to encode enumerations like this. So we already have color, so I'm going to call it C. Okay, but this is basically going to be color. So we're going to say, okay, so create a singleton-based literal type called red, or it can be green, or it can be blue. Okay, so this is an actual type. Okay, so for example, we can go and we can create a method called test. Okay, it's going to take in a C and it's going to produce a unit, and we're going to do C match case red, for example. Okay, so first of all, notice that we're getting exhaustiveness checking, right? Because we forgot to match on green and on blue. And also, if I do a red, green, blue, so that it goes away. Okay. Actually, I'm not sure if I can do case something else like this. This shouldn't compile, right? Hold on, like this. Okay. Okay, this is probably a bug, but this actually shouldn't compile, right? Because there's no way in hell that this can have this value. However, another thing, like for example, if we're calling test with red, it's going to compile, right? But if we're calling with something that is not part of the enumeration, then it's not going to compile, right? So basically, it's it's an ADT. Basically, it's sort of like an ADT, right? An ADT is essentially a sum type. You can also have companion objects, basically. So let's go and have. Let me throw out this test. Basically when I was preparing for this video, at this point, I was just playing around. Okay, so we can have an object C, and we can have values, right? So we're going to say, okay, it's going to be an indexed seek. Okay, so we're going to say indexed seek, and it's going to be red, it's going to be green, and it's going to be blue, like this. Let's also have instance by index int, index, like this. It's going to produce an option of C, right? So the implementation is the same as before, lift index, like this. All right, so Scala 3 also comes in with a better syntax for creating extension methods. So instead of doing implicit final class, what is it, like C ops, and having like a private val self, which is C, or the color, and then going over here and having, okay, let's have a method called RGB, RGB, where it's an integer, and let's do self match, and we're gonna do actually let me copy that from the enumeration, from this one. Let me go down, and I'm just going to paste it over here. Hold on, like this and like that. All right, so this is going to be an arrow to the right, and this is going to be just that. Okay, and these guys are strings. Okay, like this. Okay, so instead of doing that, we could have just done. Basically, we would define a function RGB, which would take in the color and produce an integer. And if we just swap, hold on, let me do equals 1 so that it compiles, right? So we can just swap these guys, right? So we can just take self C and put it on the left, right? And then it's going to become an extension method, okay, like this. And also you can use a space over here, or you can use a dot over here so that it sort of looks as if you're doing like the color dot RGB, okay? And then we can do that thing over here, right? And we don't need to do all of that. Okay, so you're getting like sort of a sneak preview of Scala 3 over here, right? So we have an extension method, so it allows us to to do something like rad dot RGB, right? And notice again, the type needs to be C and not rad. Okay, so something like, again, like rad dot RGB, it's not going to compile. Oh, actually, it does compile. That's interesting. I thought it wouldn't compile. I thought like the type would need to be, the type would need to be C. Okay, that's interesting. You live, you learn, I guess. So again, like at this point, I was just playing around. So I'm gonna stop wasting your time, and I'm gonna paste a couple of more things. Okay, so this is another extension method called encode, right? And what else? Okay, this is pretty much everything. So let's go and import the companion object. Import C, right? So that these extension methods are going to be visible. We're also going to have one more extension method that is an extension for strings. So these ones were for colors. This one is going to be for strings, which is why I put it like outside. So on the string, I want to be able to call replace FF with some color, right? So if the string contains, FF, I'm going to replace it with the color. And what I'm going to do is I'm going to get the ANSI code from the color, which is going to be, red, green, blue, and then put an F back in that color. Okay, and now that I have that, I can use all of these methods, right? So I can do C dot instance by index 0, for example. Okay, and I can do, map. So this is going to be the color. Okay, so on the color, I can do .rgb. This is the extension method, and it's an integer, right? So we need to convert it back to the hex string so that it looks pretty. So this is a string. Now on the string, we can call this replace FF with. Actually, let's see if I have. No, I don't. I thought maybe I have like auto completion. Okay, replace with the color. Okay, and now the entire thing, which is an option, we're gonna do it for each print line, right? Because this thing was an option. Okay, and so as you can see, we have red like this. Okay, let's do the same thing for green and for blue, and also let's make them kind of pretty and go into here, for example, and say prepend all, and let's just have a couple of zeros, right? So let's just have 2 zeros over there. It's called prepended, like this. All right, so now we can take this guy, put him over here as well, and have 4 of them over here, right? So now you have your RGB. And it's kind of cool, right? So this is, again, this would be like another alternative to encode enumerations in Scala. I'm not going to commit this because, again, I don't want to encourage you to do that because, Scala 3 has a built-in syntax for enumerations, right? But essentially, you're mixing 2 features to get this one. You can have a companion object. You can have, regular methods on the companion object. You can have a couple of extension methods in there. You import the companion objects. You work with it the same way as you would work with the other enumerations. All right. So I'm going to revert all of these changes, and I'm going to commit, the other changes after I finish recording the video, and so you can play around with, with this repository on your own. So you can just clone it, just play around like I just did. All right. So to recap, in Scala 2, make sure to check out Enumeratum, and in Scala 3, well, let's wait and see. Maybe in the future we might actually be able to use Enumeratum together with the built-in enumerations, or maybe this thing is gonna, this encoding is gonna become a little bit better. We'll see. There's no way to know. As of right now, the enumeratum, you cannot use enumeratum in Scala 3 because of the way macros work. So we need to wait a little bit until the macro situation standardizes or stabilizes. Anyways, that's all I got for you today. It's been Vlad, devinsideyou.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on Patreon and thus watch my videos before everyone else. And most importantly, take care.